Okay, this is a recording for 10/7. We're going to do most of the demos today, primarily because we got a lot of demos to do. Couple things I want to mention. There's a lot of code that I have, but there are three kind of things we're going to do. First things we're going to do is we're going to play with file descriptors. So as you can see, I can print out the file descriptors. Pretty simple. Um, We'll talk about this a lot, right? But we don't really care too much about file descriptors. We don't need to print them out. We don't need to. We just remember that they're a handle. Easy way to remember it. It's a per process table, so the process would create a new one, a new set after it stops running. So we'll talk a little bit about this, but we're going to just do some really entry level things all the way till we get to a copy. This is a full copy. It copies the file and prints it out. Tells you how many bytes to read. I'm going to play with that quite a bit, but not in so much detail that we really care that much. Not to say that P1 through P7 are useless or whatever, but they're primarily designed for, you know, unbuffered output. What we're going to do though specifically is we're going to come back and we're going to start playing with um, file pointers, right? The character get, f gets, right? And then we'll do some manipulation there. We'll count some lines, blah, blah, blah. One thing we're going to see pretty quickly is I'm going to use malloc frequently for the character lines instead of doing like for what I did in P7, which is actually create a character buffer. There's no reason not to use one way or the other, but we do need allocated bytes. We can't just use an array without it being allocated, right? So we'll get into that as we go along. The third thing we're going to do is play around with the command line. Up till now, we've had int main be basic, right? But now that we have string functions, we have the ability to take info from the command line. And we'll see how to process that and see how that actually works as we go along. Okay? Okay. So let's get started. So the first thing we're going to do is just print out a file descriptor. Not very much special. We don't ever really do this in real life, but here you go. And you notice it prints as 3 every time. You're not guaranteed 3. Um, in fact, if I do it twice, oops, sorry. I don't know why that's working that way. And I want to print out both, right? As an example. Yes. Oops, I didn't close that. Sorry. Think. I go ahead and run it. We get 3, 4. You're not guaranteed to get the same numbers every time, but it does typically start off at 3. That's not a guarantee though, as I said. Remember 0, 1, and 2 are always 1 and 2. All right, so 2, I open for writing. Notice I'm opening using the file pointer, and I'm going to use fputs. I'm going to put it in there out.1.text, and I'm going to put in there Michael Ruth and file. Yeah, it ran. You can see out1.text, and you can see Michael Ruth. Yay! Not very exciting. This is a much more typical thing we're going to do. When we're dealing with files, we're frequently going to deal with it using file pointers through the fopen process. We're putting fprints here, but I want to show you a couple other things that we can do before we move on. We can use fprint. Fprint allows you to take a file. It's not printf, it's fprintf. So now we can take a file. Now this is the same essential thing, right? It's going to print Michael Ruth 50 times, but do I do something special with it? I do. So, okay. This one's going to take out 3. It's going to open again for writing, except this time it's going to put some random numbers in there using the format. And you're like, why would that matter? Couple things. What if I just wanted to outprint a large number of random numbers, right? Like maybe I wanted test scores or something like that. I might use an fprint to give me a specific output, and then I can use, of course, scanf to go and get it. We'll see that later. Right now, we're going to stick to just, the basics, right? So now we're printing it out. Great. Now what I'm going to do is I'm going to print 3 random numbers. I'm going to go ahead and change this to 4. You'll see why later. No. Yes, I'm going to leave this to three random numbers. Da da da. And you can see I've got the numbers, right? Great. Okay, later on we'll do some calculation with it. But this is super duper useful to create a file format that we want to make sure that it prints and looks the same way. You see the new line? Boom. Now, if you go back to P3 where it just says F prints, oh, excuse me, P2, which is F puts, you still have to have the new line character in there. Just F puts by itself does not necessarily create a new line character. So you do need that. Here's one where I create 10 random numbers and I put them in a file. There's no reason not to keep doing this. So I'm just going to keep doing this. Okay. 6. F open, file name for reading. This is out 6, and I'm going to create a random number and divide it by 100. Okay. This should result in a percentage. You'll see it being printed out 0.08, 0.82, whatever. This is just printing a floating point. Because, right, remember printf allows you to take it and create it into a string. It's a very easy way to produce something that produces something like concatenation. It works very, very well. Now, okay, P7 is where we do something a little bit different. Okay, so now I want to open, but I want to use create. It turns out I don't use create. We don't use a create method. That's kind of deprecated. So what we do now instead is we open it to write. Truncate. We're gonna open a file descriptor in, file descriptor out. Okay. By doing this, I automatically cause all the program later to fail. You'll see this, right? You can see it right now. File name in, file name out, right? Great. File name in, I can just open up read only. I don't have to do anything special. File name out though, I want to open up write only. I want to open it up for create. If it's not there, I want to do it, and then O truncate. With create, I found it to be miserable not to use mode. And so what I did with the mode is I just use a basic read by owner, write by owner, read by group, and read by others, right? So it's readable. 644. I could put more in there. I don't care, but that's a default. And it just kept not working if I used anything other than that, right? So I had to use the mode. And why? Well, a couple things. One, as I said many times, we need to have default permissions. When we create a file, we don't necessarily get permissions by default, which is why I had to create them. So this only is a problem on create. If I had created the file before I did it, and I just used truncate and write only, then it would definitely not need mode to do that. You also noted that if I go over these guys, it tells you what number it is. Okay. It's 0200, whatever, but it also identifies write by owner. Okay. So it tells you what it actually is. Yay. All right. So now number read. I'm going to actually change this whole function. So the number of bytes read, we're going to go ahead and read some bytes. We're going to read from the file descriptor in. We're going to read the buffer. Remember, the buffer is a character buffer of the buffer size. And we're going to pass the buffer size as well. While the number of bytes is greater than 0, we want to write it out to file descriptor out and what number of bytes read. Now, based on this, a couple things that may seem less obvious to you. Okay. When you have a large file, it's going to read into the buffer, read into the buffer, read into the buffer. But once it gets past the size of the buffer, eventually you'll get either 1 to the size of the buffer, right? That last read will have more bytes than 0, but it will not be the size of the buffer. It'll work just right because I'm reading the number of bytes, and then instead of my write being buffer size, I'm writing out the number of bytes read. So that last one will be taken care of by that process. I'm also printing out the size of the bytes. Why this is important, I'm going to show you. So if I run the file, I get an output. Okay. Now it read by default P1C. Okay. P1C looks like this. If we look at P1 out, it looks exactly like P1C, which is great. Let's go to the terminal though, and I want to show you something really quickly. Okay. You notice the executable P7 is actually quite large. So let's try to read it byte by byte by byte. Okay. Now what I'm going to do is I'm going to cheat a little bit, right? P7 is actually an executable, right? So I want to copy the executable and I want to see if the executable is in fact executable still. Did we copy it correctly? If it's executable, we know it's executable. It did in fact copy correctly. So all I'm going to do is change P7 out. I'm going to save it. And then I'm going to go back to output. I'm going to clear it. And then I'm going to run it again. And you can see it read 496, 496, 496, and then 3864. The last one was in between 0 and what you call it. Right? Right. So P1 out is in fact P7. Let's see if it actually works like P7. So first I'm going to do is I'm going to change mode to 755 P1.out, right? This makes it executable. By default, it's only going to be read and so forth, but now it's executable. So now I'm going to execute it by going P1.out. And it works. And you go, wait a second, what? It totally works. It won't work twice in a row, though, I don't believe, because I changed the permissions. So, oh, nope, it leaves the permissions as is. Based on its, when it's not creating, it leaves the permissions as it is. The mode is only for permissions on the create process. So it actually leaves it as it is. So yeah, I can run this a million times and it's going to go ahead and copy it exactly. Is it the same number of bytes? 16,152, 16,152, it absolutely. It looks like it's actually reading um, characters, but it can read anything. This actually just simply copies a file. There's nothing special about this whatsoever. I'm going to change this back to P1C, right? To make a file executable. Okay. Couple other things. I mentioned these and we didn't really use them too often. You don't. In the create process, we do actually use them. But one thing I want to point out really quickly is we don't use this, file descriptor thing that often. In fact, we rarely use it. I was just showing you what a raw read and raw, what you call it, look like. We rarely actually do it. We're going to do the exact same thing using a file pointer in just a second, but we rarely do it, right? There's a little reason to do this in any detail. So I will also make sure you have the text, the P1 out, though you will not get. But like I said, I'll make sure you have the text files as well as the C files, right? So you'll be able to execute and run this on your own. But we rarely do this. So we don't really use the modes so often. But this is 644. Okay. These modes are actually listed in your book. Do I remember exactly which chapter? Do I remember where? No. But most of this is producing output. If you look at P12, we're producing Michael Ruth a whole bunch of time. P3, we're producing Michael Ruth a bunch of time. P4, we're producing Michael Ruth with some random numbers, so forth, right? So now we're going to go into reading process. Why? Because we actually want to do the string stuff later, right? So let's do the string stuff later. So first, we're going to go with the file open process. And so we're going to do fopen. We're going to look at out4. Out4, as you remember, is a bunch of text numbers. And we're going to read them. And we're going to do absolutely nothing with them. Oh, we're going to print them. Okay, so we're just going to keep reading and we're going to keep printing them. Okay, I want to go to output. I want to clear it. And just as a reminder, the file we're doing is out4. Okay, so let's do out4. Couple things too. You notice there are no close here. That's not great. We don't have it writing to a file, so there's no writing. It's just going to read each character, print it out, read each character, print it out. You notice also it has a new space character in there. And you go, is that character actually represented? It is. If you actually look at the file, it actually is there. If I save it and then rerun PR1 again, that is actually in there. Okay. Oops, I didn't close it. Right. That is actually in there. Yes. That's just reading character by character and printing them out. Not very special. This is just going to outprint line. There's a lot of easier ways to do this. But what I want to do now is I want to know the number of lines. So what I'm going to do is I'm going to just look for a specific character. While the character is not into file, right? Well, the character is not in a file. I'm going to read a character, fget c, and all I'm going to do is count the number of times I saw a new line. Okay, that's it. And I got 9. Let's look at out.4 and see if there are 9 actually new lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because why isn't there one after this? Because there's not one after this. The into file is met before we get to a new line. Okay, pretty simple. And that's why we see that work the way we is. But that's all it's doing is counting. It's going character by character. Fget C's, that's all it's doing. And it's counting the number of new line characters. That's essentially it. Could I count the number of ones? Can I count the number of twos? Absolutely. I certainly could. I'm not going to, but I could. So this one's a little more straightforward. Out4. What this is going to do is it's going to assume a couple things. We need to think about this a couple of different ways, okay? So we don't usually do this from a system administration point of view, right? When we talk about system programming, we usually think about system programs, right? This is probably not what you're thinking, but in typical, when we're reading text, we typically think of 80 lines of character space on the screen before you hit a new line character. That way you're guaranteeing a situation where a human could read the text. Most screens, most input lines, most things like that, standard input, a line is usually closer to 250, right? 255 or whatever. Different systems have different lines. I'm going to use 80 here just because it's going to be easier for me to use 80. Then I'm going to use fgets, and it's going to be a line. My buffer size is going to be 80, and I'm going to read it from the file. Okay? What I'm going to do is read a new line. Okay, is it going to read 80 characters? No. What it's going to do is it's going to look for, remember that here where I'm looking for the new line? It's going to read from the beginning to the new line character. And then it's going to print it out. Okay, that's it. And then it's going to read the next line. Eventually, fgets will read, and the line will not have anything in it. It will be null, right? If you mouse over null, you note that it results in 0. Okay, simple, easy way to think of it. Okay. But let's go and clear the output and run it again. And you can see it printed all the output. It printed exactly like the file looks. Yay! 28 and so forth. And it keeps reading and reading and reading. And each one of these is a new string. Okay. You note a couple things I want to point out really briefly. It does not have a new line character in it. It has the new line character as part of the string. Watch this. When I print it out with the new line character, it puts a space. Okay. What if I want to remove the new line character, right? What if I wanted to do that? I have to do something to do it. Okay, some programming languages have a chop. Some programming languages have other mechanisms. I don't really care. But that is what's happening. The new line is part of the string. So just remember that. Pretty simple, but the new line is actually part of the string. All right, PR4 is going to count the number of A, E, I, O's, and U's. Yay. Okay. Wait, sorry. That's not right. Well, line equals null. We're gonna get this, we're gonna get the length of the line. where I do loop through the length. Oh, we're simply going to print the A, E, I's, O's, and U's. That's really kind of dumb, but okay. That's what we're going to do. And which line are we using? Out.1. Let's see this. Oh, Michael Roof. So this is going to print the I, the A, E, the U, and so forth. Note, it's going to print all the I's. It's going to print the down the string. It's not going to print spaces. It's not skipping things, as an example. Um, but it's a way of doing it, I guess. I don't know why I do it this way, but you'll see it. Yes. And it's just the AEIs and O's and U's. Do I know why it's doing that? No. Could I count them? Pretty easily, right? So what I'm doing here is I'm using some of the character checks just for shits and giggles. Getting the length of the string because I'm going to loop through the string. Then I loop through the string. If it's an alpha, character check. Oh, okay. All right, couple things. I don't really understand why it's doing that. So, okay, let's loop through it. If alpha, it's alpha, right? So it's alphanumeric, not alphanumeric, it's A through Z, right? So I'm going to check the line. If it's upper, I'm going to convert the character to lower. That's what this is doing. If it's not A, E, I, or U, I'm going to print it. Okay, that's just strange. I'm not sure why I would do that, but we're going to do something similar. We're going to take it apart. It's going to print all the non-vowels. And you notice something too. It's not printing check, it's printing. So it's basically wasting my time here. Okay, let's see what the next one is. Yeah, we're going to stop 5 and we're going to do a new 5 because that is ridiculous. So I'm going to go grab 5 and I'm going to go here, print it out. I'm going to file save as, and I'm going to name it as PR5A.C because we're going to play around. Okay. So what I'm going to do is just manipulate the lines. Okay. Okay. First things first, getting rid of all that. There's no reason to do any of this crap. Okay. All right. And I want to print the line when I'm done. Okay. Okay. If I mod 2 equals 0, so I'm going to alternate, right? If it is even or odd, right? And yes, I realize I did this backwards. I'm going to put it inside the if alpha. There you go. Do, 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 do. All right, give me 1 second to get it situated. Is alpha. That means A, Z, or A through Z. Okay. All right, great. Even or odd. So here I'm going to do the same thing. Character X equals to lower is lowercase, and I'm going to go grab the line of I. And I'm going to set X. I'm going to redo this in a minute just so that we can see the difference here. Don't think this is necessary to do this in 2 parts, but you can guess what I'm doing. Okay. It's going to be a crazy string. So that means all the alphanumeric things are going to be upper or lower case. And away we go. Oops, I need to clear the screen. And there you go. So upper, lowercase, uppercase, lowercase, uppercase, lowercase, uppercase, lowercase, uppercase, lowercase, right? That's essentially it skip alphanumeric or what you call it, right? And then da da da, right? And that is doing it. All right, let's see if I can do it without the without that. Let's do it. I should be able to. It's a two-step operation in the compiler. And you go, what do you mean? Well, because of Intel systems and so forth being built the way they're built, it's a two-step thing. So this would grab the value, do the two lower, pass it, copies it by value, does the two lower, then returns it to the result of the two lower, which then writes it into line. Because it's a multi-step operation, this totally should work, right? Right. Yeah, and it does. Okay, totally does. I'm gonna leave the other one just so you can see it, but that's actually doing something. As we go through the line, we can do stuff with it. Ta-da! All right, so now we're gonna go to six. Six does a couple of different things differently. Note we're still using malloc here. Size of character times 80. We're still doing with 80. We're gonna read out that text, but this time I'm gonna tokenize the line. Now, what I'm going to mean by tokenize a line is it's going to grab each token and it's going to separate the spaces. Watch this. This is tokenizer. It's written just like the slide. There's nothing special here. Oops. And you go, Michael. Sorry, I'm going. Apologize. I'm trying to go all the way to the top. Right? Michael Ruth. There's nothing on the end of the line, right? Except that new line character is in fact the new line character is being pulled. Yes? It is a tokenizer. Can I swap it in here like this? No. Okay. It's going to produce the exact same result. It's essentially already doing that already. Yes. What can I do though? Nothing. Right. Right. I can do this. Sorry. There we go. And that'll make the printout look a little right, but it won't be absolutely correct. Okay. And you go, what do you mean? Well, we have the new line character. So as long as the new line character is part of S, there's no real way to put that there, right? Because it's only in the new line character, right? And so it does produce a couple of weird elements to it. Most of the time that doesn't care for our particular purposes, but we can do something like, uh, say if it's greater than 3, right? We can cap the size of the token, right? And that should get us that, huh, wait a second, I did this right. Okay, I did this right. Hold on. I'm going to check something real quick. I'm going to get the 9 of the string. And why is that token printing? Right? Okay. See the 7, 5? Oh, this one has the new line on it. So I got to pull the new line off. Um, don't remember how to do that off the top of my head. You know what I can do? Come on, Google. My computer's going a little slow, so I'm gonna just let it be slow. But I'm gonna go brain farting. Yeah, I know what chomp is. I want to remember how to pull off the last thing. Huh. There's not an automatic function. All right, let me look for another function. Pretty simple. This one's a little bit easier to see. I want to get a substring of C. Boy, this is really slow today, huh? Wow, this is slow. Jeez. There's no, this is an output. Yeah. Okay. All right. Here we go. All right. If string, not compare. I'm brain farting. I'm sorry. I'm forgetting the function that I'm trying to use. And as a result, I'm like screwing this up. Give me just 2 seconds to open this up. This is why we like to have our, what you call it, with us, our string functions with us whenever we're doing them. It's not string length, it is string character. Boom, that's what I'm trying to do. If string character, do. Okay. Come on. Finds first occurrence. String. Oh, and I want it off the end, by the way. I don't want it off the beginning. All right. We just want it. Oh man, this is so slow. What's up with this? I'll wait all day for that. This, I've never seen this be this slow. Yes, I know I can use string in copy. Yes, but I need to get the determine whether it's there or not. Wow. I mean, I could screw it up and just wait for it to happen, right? Like I can just. So one thing you can do if you're ever in an exam period or you're ever in a you're in a like what's call it and you're waiting for something like this to happen. One of the things you can do is you can always Oh, of course. Sorry, my internet went out. It muted me when we came back. Apologize. But yeah, my internet just died. So string character returns null if it's not found. That's all I was looking for. So we're going to print f the s just like they can with the token. But what I'm going to do now is I'm going to check to see if the token is there. If it returns null, it's not there. And I'm just going to print it out. Otherwise, I'm going to go and remove it. And you go, wait, what? Yep, I'm gonna go, well, I need a character array. So I'm gonna go 80, right? Because it could be 80. And I'm gonna set that to, I wish I could type, string copy. And essentially what I'm doing is creating a character array, and I'm going to copy, sorry, trying to use what you call it to make this work. So what I'm gonna do is I'm gonna copy the destination, which is new, and I want to copy it from token. And what do I want to do? I want to use string length of token -1. And you go, why? So what I want to do is I want to grab, I don't believe string copy returns anything. Let me double check. But we don't need, wow, I can't believe this took that long. Yeah, there we go. Copy strings for the pointers, character source size. It doesn't have a return value, I don't believe. It simply returns the destination. Yeah, there we go. Boom. All right, done. That is correct. Okay, so it copies it. The result is in new. It can actually return it if we want. But what I want to do here is just print the new instead of the token. This guy. Okay. So you're like, why did I do that? I just watched this. I just removed, I'm gonna turn video off. I just removed the new line character. I essentially created a chomp. And of course, it removed it off of the right one. Oh, I'm sorry. I got it backwards. It equals null. Remove it. Otherwise, yeah, no kidding. Come on. There we go. And it's gone. It's not putting out the new line character except at the very end. Yay! Boom. All I did was I take it off. Now, string and copy, by the way, we didn't go into this in any detail, but I'm going to do this very quickly. That was a C++ thing. String.h. You can look at the C library and you can look at the functions within the C library. You're capable of using any one of them. String and cat appends a string pointed to by source to the end of string pointed by dest. That's another one as well. String copy is the one I used. It copies the string pointed to by source to destination. Typically, you use the in copy rather than that. And all I did was I removed the length. I took a little bit off of the um, I took the last character off. Is there anything I'm missing that I hadn't gone over? Yeah. Yeah, I don't care about collate, and that's stupid. We never use that. String concatenation, we do that every now and again. We want to append things on, but usually it's uncommon, so I don't really care about that as much. But yeah, that's all we're doing. PR6. All right. So PR7, we have output. And now I'm taking the line, I know they're lines, and I'm gonna actually get the number and I'm gonna print it out. Oops. Yep. And what was it? Out 5. The last one was 57. And you go, wait a second, what about all those other numbers? So A2I takes the line and it breaks it up. The first number it reads is going to be the what it is. Now this one uses scanf and it remembers that there are 3 different variables. So this one's going to read it and it's going to scan it. So it's going to use scanf just like you would if you were doing input and actually grab the 3 variables. And the last variable is going to be 3. It's going to be -1. Okay. Now, why does it do that? Because, wait, fscanf returns the number of things it's read. So if it's not reading 3 things, it must have no things. And that's what you see here. Okay. And that's just reading with scanf. We don't do that often, but when it is fun to do, we do in fact do it. All right. CL1 is a command line one. And then you can see I have an argc followed by an argv, which is an array of characters. These are an array of strings. Now watch what happens when I click run here. Okay, the 0th command is always the command that runs. Now I go back to the terminal and I type CL1 who dat say the beat them Saints. That's what Saints fans say when they're going to play their team. And you can see the first thing that you read is the 0th argument, which is the command that you actually called, followed by who dat say all the command line arguments. Yay! What if I want to put 2 command line arguments together? I can do this, and it's happy as a clam. Wait, shouldn't have done that, right? Yes, totally works. But this is just reading command line arguments. But here's how we can see if we have the appropriate number. We can see if a flag was set. We can check the number of arguments. We can loop through them. If we see an S, the flag is set, and print the arguments and see if the flag was set as an example. So you can see it ran CL2, no flag was set. I'm going to run CL2 with all these arguments. It's going to look the same as CL1, but now I'm going to do -2 and -S. And you can see now the flag is actually set. So we do this a lot when we want to set a certain type of flag like S or whatever. We do as it's passing through the arguments, we check for the flag we're looking for. We also do things like this. So if you have an incorrect number of arguments, we're going to go ahead and do something about it, right? So in our case, we're going to say if you have less than 2, get me more arguments, okay? Note, if you have 0, 0 is the name of the program. This is always going to have 0. So you can always get the name of the program that's run. But in this case, I'm going to say a string compare and 1 and 2, okay? By default, it says incorrect. So, hey, how do I use the program? Note, I'm actually using the argument 0. How do I run the program? With a tab followed by argument 1, argument 2. Okay. Go back to our terminal. What was this? CL3. And go with who dat, right? Who is greater than dat? It goes later in the argument. So, yay. What about me? What about me space? What about me 3? Right? Me 3 actually is a different argument, right? Adding the space has no impact, right? Because you're doing the argument. So it's just going to split it into another argument. What about if I add a third argument? The third argument is never referred to, never looked at, never whatever. So that's fine. And that's pretty standard in the C language. All right. Now I want to go ahead to the terminal. And I want to remember where I am. And I want to go out to code or copy and CD 107. And I want to copy text. And I also want to copy, actually, let me copy all the text, right? I just didn't copy initially, right? Okay, great. So you can see I have Frankenstein, literally, quite literally Frankenstein. Okay, not joking. Okay, and then we have the U.S. Constitution as well. Whoa, right? Now, what I told you guys was we're gonna do a command line thing. So I'm gonna do it this way, right? I'm gonna use command line two because it's probably the closest one to what I want to do. And I'm trying to copy it all, but it's not letting me. All right, and then I'll new text file, right? And we'll start off here. We're gonna save it as uh excuse me. We're gonna save it as longest word, right? Dot C. Okay. We're gonna command line argument. It's only gonna take one, so we only need one. And then we're gonna do S and then file name. Okay, that's all it's gonna do. Okay. Now, what do we do when we do the file name? Two things. Number one, we're going to go back to PR, whatever, one of the later PRs, and we're going to do an open. We're going to do a character line. We're going to do all this stuff. Yay! Longest word. Which file are we going to open? We're going to open the one given to us by the file descriptor, right? And we're going to read it, remember live. All right. We need a longest word. And how big can it be? Let's go with the size of the line. Let's suppose a whole whatever. Okay. Let's just say, ow, sure. I just stubbed my toe. Need a line to read line by line. To remember the longest word. Read until. All right. So we need the longest line, and we also want the size of the longest line. So int size of the longest word. And we're going to start it off to be 0. We can start it off to be 0 because any word bigger than the size of the longest word is pretty clearly going to be what you call it. Now, I'm going to cheat a lot. Okay. I apologize. I like to cheat. Um, sorry. But what I mean by that is really specifically, I'm going to obviously use the string tokenizer, right? Clearly going to use the string tokenizer. And yep, there we go. You can just do this. Nope. Yep. That. Remember, you have lots of code here, so I can just copy and paste quite a bit of this. So now I want a token. Okay. Now, this actually strips that new line character off, right? Right. I don't want to print anymore. Okay. Excuse me. Let me fix this tabbing. There we go. I don't want to do this anymore. Okay. What I want to do Oops, I actually want this here. Okay, all right. I'm going to create a pointer to a final token. It's going to be null. Okay. Right. Right. So whatever the result of this operation is, we're going to get a final token being set correctly. Right. It's either going to be new or it's going to be the original token. And that's going to allow me to do what I want to do outside of this if statement. So I don't have to do it twice, essentially. All right. And that is wrong. I'm going to fix that as well. There we go. Now what I want to do is if string length of final token is greater than, I think it's the longest word, yeah. Should have actually typed it out, right? Then I want to set longest word to be equal the final token, right? And then size of the longest word to be the string length of the final token, right? Okay. Now we got pointers going everywhere, but this should result in the token being either the actual token, a string, and then it gets reset and so forth. Yes? Do. Okay. So now at the end, we're going to be, oh, you know what I want to do too? While I'm here, I want to go print F on this word, S space new word. Every time we're setting the new one, every time I'm setting it, I want to actually grab it. Final token and size LW. Yes. So this is just going to, every time it's set, it's just going to update it. Okay. So this obviously the N one should result in the same one. Now we want to do if, no, we'll do this. So see the size of the longest word, and that guy is down here. So at the end, we just want to print it out. Just print it out. You should have already done that. So I'm going to just do this. I'm going to go print F and make sure I have a new line. I'm going to comment the one above out once I actually verify that it's doing what I think it's doing. But let's start off. Okay, first of all, we're going to read the file. Yay! We have a line and we have a longest word. Yay! Okay, so what we're going to do is we're going to continuously read the line. As we read the tokens, we're going to process the tokens, and it's either going to be the token or it's going to be new. Okay. One of the two. Once we're done with that, we're going to see if it's bigger than the last. Yes. If it's bigger than the last, save it, right? And print it out. Obviously, we want to print it out just so we can see. And then token equals null. Okay. Now, one would argue that there's really insane to use such a big file. Yes? Why would I use such a big file? One, what difference does it make? Right? Is there no standard lib at the top? Oh, no, there isn't. That should solve those problems. Let's get this compiling. Okay, get a segmentation fault. That's because there's new argument. Okay. Go back to terminal. Actually, it should have reported that. All right. CL. Nope. Longest word. All right. Is it not compiling to longest word? Hold on. It is not compiling. Okay. It's actually still having it. Oops. Sorry. Apologize. Let's go to terminal. Longest word. And I'm sorry, what is it? Longest word dot C. Oh, it is there. Yes. Right. So the first word, are you serious? So the first word in the file is named Frankenstein. The Then it becomes physiological, disappointment, disappointments, fellow professor, and self-satisfaction. But look at the last result. It says longest word is Vess, 18. At some point, because the line of word, I'm using this final token. At some point, it might be grabbing the new. So wonder if I should string copy both times. Because that's what's happening. It's just taking the final token um, and modifying it. Longest word is pointing to the final token. So when the final token changes again, it's modified again. Does that make sense? We don't want to do that. You know what an easy way to do that is? Just do string copy, source destination, longest word. Destination and source is final token. And I'm going to cheat here again, and I'm just going to grab the longest word here, and that should correctly do it every, oops, I did it again. And that should do it every time. Yep, there you go. That solves the problem. This is the problem is when it did this, it was automatically setting the final token one last time. And then the longest word was still pointing to the final token. So the last time it printed out incorrectly. So you just string copy. 90% of that can be solved by string copy. A couple of things I want to point out if you care. If I go ahead 5, Frankenstein. The very first word is Frankenstein. Now, I knew this because I was cheating, right? And I knew Frankenstein would come first at 12. But the longest word is self-satisfaction at 8. Let's do the same program for U.S. Constitution. Text. Oops, type some random thing. right? Yeah, we got some weirdness. But the longest word here is representatives, and for some reason it is 17. Not quite sure why we get this weird thing here. Not quite sure why we get that at all. You get the space, and you get a new line character, and then you get length. Not sure why that's happening, but that is representative at length. Actually, I'm gonna type that again. Just do that again. Makes no sense. Why it's switching them. Let me see. String copy. Final token to log word. No, there's no f print f. I don't know. I'll look into this. I don't really care. But this is the longest word. This is an example of that. We're just playing with a array, and we're at 2 hours now, or we're at an hour. So this is a good place to stop. I'll look into this. But slicing and dicing, you have this whole string array. But one thing that we didn't talk about that we will talk about in the very near future. Remember, I'm not going to share. I'll share the Constitution with you. There's no reason not to care. Um, oh, I think I know what's going on. So there is junk in here, and it might grab 17 from somewhere. But that makes no sense. I'll look into it. It doesn't look like it should be wrong, but I'll look into it. Um, Probably something simple. One thing I can do too is I can just take off the new line character. The new line character would have little or no impact in the final thing. But like I said, I don't really care. We're at an hour. This is good for today, first day. We have a large number of examples here. Remember, I'm going to remove anything that resembles a executable. Remember never to share or try not to share executables. It results in not great things. So you never want to actually do that. But yeah, this particular thing where we have the arguments, it works great for Frankenstein. I'm not sure why it's switching the two. Because that's what it's doing, by the way. For those that don't know or can't see, that's all it's doing is switching S and length, right? It's taking the length part and switching it, and I don't know why. Probably because there's a weird printing character in there, and I don't really know. I'm gonna try it with a couple other text files and just test it out. It's pretty simple. And I can also take the US Constitution and just break it into parts and then try to see if it's some weird thing inside there, like a non-printing character that it's getting annoyed with. It doesn't really matter for the purposes of this. However, when you run into things like this, immediately come and ask, right? So the people, switch to people, then switch to states, and it's just tranquility, constitutional, and then representatives. Note it says representatives with a period. That doesn't seem odd to me at all. But all right, if you have any questions, remember I'm online this week. If you have any questions, please ask. And note that you do, I think, have a homework coming out this week. It's not due this week, it's due when I come back. But look out for that. All right, thank you so much.